and go slow. So make sure you pay attention during this because it's really pretty easy if you know what you're doing and you understand what you're doing. So we're going to start out with a basic inequality first, a quadratic inequality. We're going to solve it, and I'm going to help you kind of understand what you're solving here. And we're going to put our answer in interval notation. This is going to help us build up to the harder stuff. If we understand the more basic stuff, we understand the harder stuff. So if I said to you solve this inequality, 2x squared plus 9x minus 5, when is that function less than or equal to 0? When is this function less than or equal to 0? So what this is really asking you guys, if I were to graph this function, 2x squared plus 9x minus 5, here's a rough sketch here. It's saying what intervals for x, we're solving for x, what intervals for x is the function less than or equal to 0? Do you see how below, on that interval, that's when our function's below less than or equal to 0? Does everybody understand? For what? Okay. So we can solve this a couple different ways. We're going to go through it, and I'm going to show you how you would do it algebraically, because that's how we'll do the harder ones. So won't it be between this x value and this x value, this x-intercept? Okay, so let's just, instead of having this less than or equal to sign, let's just set it equal to 0 and solve it, because then we'll be finding the x-intercepts. So we would solve by factoring. So this is going to factor to be what multiplies to be a times c, adds up to be b. I'm just going to show you should be able to do that pretty quick. So this would factor to be 2x minus 1 times x plus 5. You could go through the whole process. Now we would get x is equal to positive 1/2 and x is equal to negative 5. So that's negative 5. This is positive 1/2. So we're solving for the x values, the intervals from where this function will be below or equal to 0. So isn't it between negative 5 up to 1/2, everybody? That's the x interval for which this function. Does it include, isn't that when it's equal to 0, you guys? So it includes, because less than or equal to, so we would put a bracket. So this would be our final answer here. So everybody see how I did that? Now I'm going to show you one other way how I would have tested this. Instead of looking at it graphically, if I would have tested it like this instead. This will help you see how we're going to do the harder one. So instead of doing it by using the picture, if I was just to draw a number line here, and we know our x-intercepts are 1/2 and negative 5, I'm going to put in just like a 1/2 and a negative 5 in here. So now you could test values below negative 5 and see if it's a true statement. And if so, that would be your answer. So let me show you what I mean. For example, if I didn't want to graph it, if I said, okay, I'm going to test in this interval. Do you see what I mean? Values less than negative 5, everybody. Okay, like let's test some number less than 5. Any number less than 5. So let's test negative 6. Why not? So test negative 6, because that's less than 5. So plug in negative 6 up here. Everybody, you type it into your calculator. 2 times negative 6 squared plus 9 times negative 6 minus 5. You get 13. You get positive 13. Look at the statement. We want this to be less than or equal to 0. Is 13 less than or equal to 0? No. So we know this is a no. This interval from negative infinity up to negative 5. Everybody understand? So we know that that's a no. Let's do another interval. So let's test values between negative 5 and 1/2. Any value will work. Let's use 0 because that's the easiest, right, everybody? Isn't 0 between negative 5 and 1/2, everybody? So now I'm testing 0. So plug in 0, we get negative 5. Is negative 5 less than or equal to 0? Yes. So do you see how we know for sure that this portion is in our solution? Is everybody seeing how this is working? Let's test something over here, something greater than 1/2. Let's just test 1. That's a good idea. We get 6. Is 6 less than or equal to 0? No. So we know that this isn't in our solution. So then we know because we're equal to, these were negative 5 and 1/2 or when it was equal to 0. So now we were able to use this method to solve. So we knew it was between negative 5 and 1/2 because that's when we said yes. Does everybody understand? Okay, let's do a little bit more advanced one now. We're doing the same idea though, and we're going to test it by this method because graphing rational, graphing rationals isn't our favorite, right? Let's be honest, graphing a rational polynomial, number 3-4. So we would want to just test it using this method right here. Okay, let's do this example. So write it down on your paper. You're going to want to refer back to these for sure. They're not easy. So we're going to solve the inequality, and we're going to put our answers in interval notation. So instead of graphing a quadratic and answering when the function is below 0 or above 0 or whatever, depending on the problem, we're going to be doing this with rationals. So right now, notice how it's not equal to 0. I'm going to do it equal to 0 because that's easier to see. Does that make sense? Everybody, just like in the other one, we were looking below 0. It's easier to see when it's below 0. So let's make this equal to 0. So we subtract 3. Remember, you can add negatives and subtract negatives with inequalities and not change the sign. The only time you have to change the sign is if you multiply by a negative or divide by a negative. So we're good. So we have x over 4 minus x and minus 3 is less than 0. Does everybody see how I just rewrote it? Because it's easier to see when it's below 0. Okay, now let's make this one rational, easier to test here. So let's get a common denominator now and make this one rational. So this is over 1. Want our least common denominator be 4 minus x. So we have an x, and then right here we have negative 3 times 4 minus x. And we're going to distribute that because now we have a common denominator, right, everybody? So we've got to remember that we always distribute and combine like terms before we try to simplify, right? Okay, so we really have x minus 12, distribute that through, plus 3x. So isn't that 4x minus 12, right? Yeah. Over 4 minus x. I'm going to go that down. Over 4 minus x, and that's less than 0. Now we can see if this simplifies, so let's do that just for kicks and giggles. On top, we would factor out a 4. Left would be x minus 3. And on bottom, we have 4 minus x. So nothing divides out, correct? Okay, so now all we're doing is I'm asking you, for what intervals of x is this function below 0? Does everybody understand? So we're going to test this using that little method we just used. So these are the values you're going to need. You're going to need your vertical asymptotes. We're going to be testing those and our X-intercepts. So let's look at this and first determine our vertical asymptote. Isn't that when it's the bottom equal to 0? Isn't that what creates the vertical asymptote or hole, everybody? Does 4 minus x divide out with anything on top? No. So we know we have a vertical asymptote at the discontinuity, which would be x equals 4. So that's one thing we're going to test. I'm going to put a 4. Everybody good? And then we're going to test our x-intercepts. Now remember, that's when y equals 0, correct? So I'm just going to set this equal to 0. Instead of I'm going to pretend like this is an equal sign. So we have 4x minus 3 over 4 minus x equals 0. Let's solve for x. So when we multiply the bottom up, everybody? So that would be 4 minus x, 4 minus x. So those divide out. So we have 4 times x minus 3 equals 0. Isn't 0 times anything just 0? So isn't solving for the x-intercepts just solving for the top? Remember that? But here's algebraically why. So solving for x, won't it just be 3, everybody? Couldn't we set each of those equal to 0, but 4 doesn't equal 0, right? There's no variable. So x equals 3 is the only x-intercept. So now let's go put in a 3. That would be below 4. And let's test each interval. So do you see how we have 3 intervals we're testing? So now we're going to see when the function is less than 0. Just not intercept, but like intervals, because we're testing down here, in the middle, and up here. Does that make sense? Okay, so let's test a value less than 3. How about 0, because that's the easiest? Everybody good with that? So I'm going to write that. Let's test 0 and see if our function's less than 0. So you can plug it in anywhere. I'm going to just plug it in right here. Why not? So I'm going to do it right here. 4 and then 0 minus 3, correct? over 4 minus 0. What does that simplify to be? Negative 12 on top, correct, everybody? Divided by 4, which is negative 3. Is negative 3 less than 0? So we'd say yes, so that's going to be in our solution. Does everybody understand how I'm doing this? Okay, let's test between 3 and 4, so 3.5. Okay, so let's plug it in. So it'll be 4, testing it right here, and then 3.5 minus 3 over 4 minus 3.5. What do you get? Make sure you type it in right. We're all calculating this, right? You get what? Did anybody else get 3? Okay, so we're typing, one of us is typing it in wrong.
Yeah, Andrew and I are right.
Okay, guys, you have to calculate the top, then calculate the bottom, then calculate the whole thing. You got 4. Yeah, it is 4. Okay, so we tested 3.5 and we got 4. Is 4 less than 0? No, so in this interval is not a solution. Does everybody understand that? Okay, let's test something greater than 4. So let's test 5. So testing 5 because that's greater than 4 and you get negative 8. Is negative 8 less than 0? Yes, so we know that this is in our answer from this interval and this interval, correct? Because that's where we said yes? Okay, so coming in from negative infinity up to 3 is a yes, correct? And then is 3 included? Was it also equal to 0? No, so we get parenthesis, parenthesis, union. Also, 4 to positive infinity. 4 is not included because it wasn't or equal to 0. We know that's when it's equal 0. 4 to positive infinity. So there's our answer. Not too bad, right? Really not too bad. Everybody feeling good? That's our answer, right? That's the truth. That's when our function is less than 0. That's both answers. Union. Okay, let's do this one, and then we'll do one of the test review, and then I'll let you just work on the test review the rest of the time. So here we go. So solve the inequality and put in interval notation. So once again, it's easier to compare when it's equal to 0. You can do this a couple different ways, but I like to test when it's greater than or less than 0. So let's, we can do this a couple different ways. I'll just bring this over this way. So we have x plus 1 minus x plus 5 over x plus 2. We want to know when that is greater than 0. Does everybody understand? Because I brought this over this way. So now it's 0, right, everybody? Are we all seeing what I did? Subtracted that. So let's just have one function here. So let's get a common denominator. So this is over 1. So we'll multiply by x plus 2 over x plus 2. We got to use parentheses here. And that would give us a common denominator, right? So let's distribute this through on top. You got to distribute and combine like terms on top. So we'll have x squared. So we'll have x squared plus x plus 2x plus 2, correct? Now, it's subtract all that stuff, so we'll have minus x minus 5. That's where most people mess it up, right? They forget to distribute the negative. So let's combine like terms. On top, we have x squared. We have plus 3. Oh, no, let's see, plus 2x, right? My x minus x. And then minus 3, because 2 minus 5. So that's on top, and on bottom, we have our x plus 2. We want to know when that function is greater than 0. So what we're going to do is we're going to factor out the top so that we see if it simplifies. Everybody good? So let's factor out the top. What multiplies to be negative 3 and adds up to be 2. 1 times 3, negative 1, positive 3. I can quick factor because my a value is positive 1. So the top factor is to be x minus 1 times x plus 3. And on bottom, we have x plus 2. And we want to know when's that function greater than 0. Everybody feeling good? So we're going to test, yes?
So when you're like,
yeah, we're just subtracting that entire side. So we're subtracting this entire thing to make it 0. So now it's equal to 0. What do you mean minus 5? Because we got to distribute the negative 3, right? When it's subtraction of polynomials. Okay, good question. Okay, okay, let's continue this. So now we're going to test, we know we got to test our vertical asymptotes, and we got to test our x-intercepts. So x plus 2 doesn't cancel out with anything on top, doesn't simplify, so that's a vertical asymptote at x equals negative 2, correct, everybody? So that's going to be somewhere we're testing. And then we're going to find our zeros. Isn't that when the top equals 0, guys? Because when we multiply up, won't that become 0, everybody? Yeah. So won't our x-intercepts be x equals 1 and x equals negative 3? Everybody good? So we're also testing negative 3, and we're testing positive 1. So we have a few different intervals to test here. So let's test something less than negative 3, negative 4. So I'm testing negative 4. So you can plug it in into the function. Make sure you simplify correctly. Is everybody good with that? Can I just tell you what it is? Yeah. Yes? Yeah, either or will work, actually. So I would plug it in here, but either or will work. Just make sure you can simplify it correctly. So we need to plug in negative 4, hit enter, and calculate the top, then divide by the bottoms. Everybody good with that? Okay, so you get negative 2.5. Is that greater than 0? Right, we're looking for greater than 0. So this one's a no. This interval's no. Let's test between negative 3 and negative 2. So let's test negative 2.5. Everybody good with that? Yeah. If you plug in negative 2.5, you get 3.5. Is that greater than 0? Yes, so we know that interval's in the answer. Okay, let's test between negative 2 and 1. Won't 0 be the easiest? So let's think about that as 0 minus 1 times 0 plus 3 all over 0 plus 2. So on top, won't we have negative 3, and on bottom, over 2. So is negative 3/2 greater than 0? No. So we say no, that interval is not in the answer. We're getting down to the end here. Let's test greater than 1. I tested 2, but any value will work. So test 2, plug in 2. 2 minus 1 times 2 plus 3, all over 2 plus 2. Well, that's going to be positive, right? So we can automatically, we don't even have to calculate, say yes. Everybody understand? All right, so our answer is, well, it's a no from negative infinity up to negative 3. It's a yes on this interval. So from negative 3 to negative 2, we had yes. Did it include when it equals 0? No. Okay, now we got to be careful here. Is negative 2 ever a solution? No, right? Because that can't be. So we'd make sure to put a parenthesis. Okay. So if it was or equal to 0, this would get a bracket, right? If I change the problem to be or equal to 0, wouldn't negative 3 get a bracket? But negative 2 would still get a parenthesis because it can never equal 0. Does that make sense, everybody? Okay, let's move on. Union from 1 to infinity was also a solution, but because it's not equal to 0, 1 is not included, so we're good. So I'm going to just, once again, say that one more time. If I was to change the problem and say or equal to 0, this would be a bracket because negative 3 is okay. This would still be a parenthesis because negative 2 can never be a solution, and this would be a bracket because that is when it's equal to 0. Does everybody understand? Okay. Let's do one with the test review, and then I'll just give you the rest of the time to work on the test review. So number 27. So once again, we are solving for when this function is less than or equal to this function. I'd rather compare it when it's less than or equal to 0. It's just easier testing in my book. So let's just get this equal to 0. So I'm going to bring this function over. So I'm going to be adding 3 over x minus 7. So we have 6 over x plus 2. Now we're adding 3 over x minus 7. Does everybody understand why? So I brought this over using algebra. When is that function less than or equal to 0? Isn't it? On the test sheet. Okay, let's get a common denominator. So this needs an x minus 7. This needs an x plus 2. So let's distribute the top. So that's 6x minus 42. It's addition, so we don't have to be careful. Plus 3x plus 6. That's on top. Let's combine like terms. So 9x minus 36, right? That's on top. And on bottom, we have our common denominator, x minus 7, x plus 2. When is that function less than or equal to 0? So let's factor the top to see if anything simplifies out. So I'm going to pull out a 9. Left is x minus 4. And on bottom, we have our x minus 7 and our x plus 2. We want to know when is this function less than or equal to 0? So we're going to test our vertical asymptotes and zeros. And x-intercepts, which are zeros. So we draw our little line. Let's figure out where are our vertical asymptotes. None of them divide out, correct? So at x equals 7 and x equals negative 2, we have vertical asymptotes. Okay, let's find our x, those are our vertical asymptotes. And then our x-intercept is when the top equals 0. Want it to be at 4. Everybody good with that? So our x-intercept was when x equals 4. Okay, those were our vertical asymptotes. Okay, now let's test all those intervals. So below negative 2, let's test, what do you want to test? I tested negative 3. So if you plug in negative 3, you get, and we can plug it in a couple different places. We can plug it in here. We can plug it in right here. We can plug it in back in the, you know what I mean, everybody? So make sure you can do that correctly. You get negative 6.3 roughly.
Yeah.
Okay, negative 6.3 is what you get. Is that, and this one we're looking for less than or equal to 0. Is that less than or equal to 0? Yes, right? Less than or equal to 0, so that is. All right, and then let's test between negative 2 and 4. Let's test 0, because that's the easiest. If you test 0, won't that be negative 4 over, you plug in 0. Oh, never mind, that won't be negative 4, sorry. Plug in 0, that would be negative 36 over negative 14. Won't that be positive? Everybody, do you understand what I'm saying? So you get positive. So is that's not less than or equal to 0, correct? So we'd say no. Let's test between 4 and 7. So I tested 6, but we could test any value. So I plugged in 6 and got negative 2.5. Is that less than or equal to 0? Yes. Let's plug in now something greater than 7. Let's test 8. If you plug in 8 into the function and calculate it correctly, you get 3.6. Is that less than or equal to 0? No. So our answers are where we get yeses. So on this interval, ding ding, and then this interval, and then it includes 0, correct? Everybody, so we'll be really careful as we do this. So we're coming in from negative infinity up to negative 2. Infinity gets a parenthesis. Is negative 2 a vertical asymptote?
Yeah.
So we know that it can never equal that either. So we do a parenthesis. Union, and then from 4 to 7 is a yes. So on the interval from 4 to 7. Can 4 be included? Isn't 4 when it was 0, guys? 4 can be included, correct? Can't the top be 0? But the bottom cannot. So 7's not included. That would be our answer. It's not too bad, right? It's actually pretty easy as long as you know what you're doing. Okay, awesome. That is it. The rest of the time is yours to work on the test.